Hi everyone. Um, so just gonna wait a little bit to get this started. I'm hoping that this time archiving has been turned on. I double checked it, making sure that my picture shows on Twitch. And not seeing it. There we go. Cool. All right. So hello everyone. Today I'll be putting the disassembler into a UI window. Off stream, I went ahead and completed the rest of the disassembler. All the opcodes are should be accounted for here. So the first thing is I saved all the disassembled instructions to this variable. I don't foresee actually really using this variable. What I'm probably going to do is save it directly to the CPU state. So let me see. So what I'll probably do is add a field to the CPU struct. So let's see. Actually, you know what? I think I'm going to just create a function that returns a or rather fills out a character array. So let's do that actually, and we'll go from there. So actually what we need to do is just pass the CPU, and we should be end the MMU. So let's see. So disassemble instruction. Disassemble rather current instruction. And we'll just take the instruction from the CPU program counter. So what I'm going to do here, so I just copy and paste all this stuff. Okay. All right. So, and we'll take car disassembled instruction. So the return disassembled instruction here. So instead of doing this, I will stick this here. So that should work. Oh, you can't do it in array len. Pass in or len excellent. For some reason, Vim has been acting up, and it takes a while to actually backspace. I don't know why. Let's see. Does it not like this? Factory U64. That's why. I'll make this size T, I guess. So this should compile. Yes. So unused. And let us try and actually just disassemble an instruction and stick it in the UI. So my plan for this is to stick it underneath this next instruction thing. So let me do that. So let's do car assembled. Instruction. It's just 32. Close up braces. IM GUI. So this will be disassembled instruction. And instruction. CPU review. And of instruction. Oh, whoops. Yeah, this doesn't return anything. I could have it return the. Actually, I could have it return like the disassembled instruction. But let's do this instead. I spelled it disassembled instruction. I should change that. Okay, let's see if this works. Yes. So as you can see, those instructions are right there. So let me actually pause. So this is instruction 28. This is a jump relative. So I can actually confirm this. This is 2.8 jump relative if the Z flag is on. Yeah. All the jump instructions I'm pretty confident with. Otherwise, I think the BIOS wouldn't work well. Rather the boot ROM. So, yeah, F9 to its complement, I'm sure is -7. That's rather negative, -9, I think, because you added 2 to it. So, okay. Now that we have this, so this is good, but the problem is that this is dependent on the current program counter of the CPU. So what we probably need to do is, instead of disassembling it at the program counter, well, we'll keep this. The fact that the next instruction is this. We'll keep this on the UI, but what I like to do is create another window that's literally a disassembled version of all these bytes. So what to do? So we'll need I know we'll need to start disassembling from an address. So ideally, address 0. So instead, let's say this. Let's say instead of taking in a CPU, we'll take in a 16 address. Right? So rather start address. So we don't have the CPU. This is start address +1. Right. Okay. So we need to do here, this will become CPU PC. Now we should have the same stuff. Oh, I even need to do that. Right, if we stop it at 28 again, we get the same instruction. So, so we have that. So now, what we need to do is, what do we need to do? What we let create another window that uses this. And so first we'll start disassembling at address 0, but let's create that window. So in IMGUI, create a window by using the begin method, begin function. And so I will do the same. I know after this it's going to be hard. I know the windows will be a little bit overcrowded, but I'll deal with that later. So let's do this. Let's create it. Yeah, this looks like a good size. I can make it even probably a little bit thinner, like 200 pixels. So this is the disassembly. So what's the first step? So what you need to do is create a create a child scrolling. So this is a child view within the window. The set window post actually does not work because what I tried to get it to do was it starts up over here. I wanted to start up over here, but apparently this is only set after the first iteration of the IMGUI frame. So after the first frame, then this is populated. Because yeah, it doesn't know the window size until after the first frame. So I'm gonna ignore that for now. Actually, you know what? I'm going to fix this. Post is not set until the second frame. So what we'll do here in child, there's also an IMGUI. So make sure we end properly. Go inside or outside? I'm pretty sure it goes outside. Yeah. Cool. And I am GUI and child. So I will change this to assembly. IMGUI uses a hash map to store the state of each element in the UI, and so the double hash means don't display this, but still uses the ID. And this is useful if I had multiple windows named disassembly. I would do like ##1 for one window, and then the next window would be ##2, etc. I didn't really need to call this anything significant, but just for readability's sake. So what I'd like to do is this will count up by 1, or rather by the amount of bytes per instruction, uh, which leads me to remember that I need to, in disassembly and function, I need to also have a output for the amount of bytes of the instruction disassembled. So what does it do? It does like 8. Does it do? No, these are more than 8. Oh, it's 8 per row. I think that's what that means. So you can also make this bigger. Yeah. Okay, I don't think I need to do any of this, really. This clipper is used for the scrolling. So line total count is literally the address space. Let's actually I need to calculate this first. The line height is literally just GUI line height. Yeah, get text line height. That's it. Okay. So I need to calculate this. So well, there's somewhat. Let's try and do it the most obvious way first. So first thing is, let me loop until the entire address space actually. So so let me go back into where is the this let me rename this actually. This parent. Let's just do this. Correct instruction. Let's disassemble starting at address. God, that's a long name. At address. Yeah. Okay. So I need to output So this is the out disassembled instruction. I can just return this. It really doesn't matter. Yeah. Can either return it or have it as an out variable. I'll return it. Do C style. Return bytes. Non-bytes per instruction. So starting at 0. Actually, let's do this. While I do this. Is the increment of I will vary. So I less than disassembled instruction starting at starting at I. Disassemble. So, or actually, explicit. Yes. You. Then we have auto. Let's see. By 32. No, fuck it, let's use auto. This maybe might change my mind and make it a I-64 or something. There's no point, but whatever. Num bytes. Actually, I'm going to do this. Parent address. Now, well, in this case, actually, I'm just calculating how many lines there are. So I actually don't need the disassembled instruction itself. This might be very expensive to do, but let's see if this is a bad idea. address, then it's 2. Two lines. Lines. So no. Oops. This is here. Okay. So I'm going to do a very similar. So next step is we need to populate the clipper. So let's see. How does this work? Okay, so yeah, makes sense. This. And this represents the start of the scroll box, and this represents the end of the scroll box. So what we shall do trying to figure out how, without storing a giant table, trying to figure out how I'm going to. So let me write out exactly what I want. I want this. I want the address colon the instruction. So actually what I'm thinking of doing is this, because what this does is it actually uses legitimate assembler syntax, and then makes the address row a comment. But let's do this for now. So this is what I want. And the idea is, how do I know what the address is? How do I know? How do I even know what address I need to disassemble? And I feel what I could do is have my 32 array of number of I hate this, but I think this is probably the more obvious way of doing this. I literally have an array of start addresses for each line. So address per line. And I have push memory instruction, program memory. It's I hate that the autocomplete doesn't work in macros. Why is that? General memory. Memory. And what do I, how many, oh, no, to this, num lines, and then this is of type 532. Yes, take the address. So, right, that I have a auto memory AM. This is, I got this inspired from Sean McGrath. So equals auto memory. I don't remember the, okay, stack in the memory. Okay. What this object does is it auto freeze this memory at the end of the scope. So address per line. And by freeing, I mean it just pops the stack, which is just moving a couple pointers around. Moving one pointer around. So the address is address actually, what I'll do is this. I'm on 0. Create max of that, and every time we see a line, we num lines, so address per line at num lines is equal to current address. Okay. This is stupidly expensive, but well, 65,000 iterating. It's unnecessary. I'll have to figure out a way to simplify this. So what we need to do next is line address per line at line, and then the disassembled instruction address line. In this case, we will need disassembled instruction 32. Array 1 of the disassembled instruction. Don't need to do this. I keep forgetting it doesn't return the actual character string. Since it looks like these are used for two different things, I might separate the disassembled instruction into two different functions. One to calculate how many bytes it is for that instruction versus how to disassemble that instruction. But I'll get to that later. Just per line. Yeah, I need to be in this loop. Actually, this would be a U16. These are U16s because they're addresses. And then this is the disassembled instruction. Okay. Current address should be 16. So let's see what we have so far then. Oh, already crashed. That's great. What's the issue here? Lines. Ooh. It's way bigger than F. Address. I'll have to make this U32. I32, fine. And then I'll have to 44. Yeah. This needs to be a U16. And then this needs to be a U16. Yeah, okay. Let's try that. Okay. Nope. Yeah, this doesn't seem right. Current address and current. The reason I increased the size is because it may go up to, so it doesn't fill up the entire address space. Because this should be less than this. Um, or rather, num lines should never go above this value. Let's do an assert. Assert. This is less than that. Okay. So where are we now? Px num lines. Okay. And p current address 96. That's not right. Oh, I know why. Because I'm passing in the address, not the value at the address. Whoops. This might actually. Current address. This might actually work. So let's keep this EU16 for now. If it becomes a problem, we'll change it. So what I need to do is well, wait, no. It takes in an address. It doesn't take in the actual instruction. Yeah. Well, yeah, I'm not expecting. Don't fully understand why this because this should return a value of 1 to 3 and no less than 1. Well, let's step through it then. All right. Okay. So step into here. 3. Good. So right. That's right. Break again. Then let's step. Current address should be 4. And num1 should be 2. Yeah. Okay. Well, it's actually an easy way of doing this. Let's do this. And let's do a 32 bytes. Bytes. Co-assert. 7 bytes are always greater than 0. Actually, there's a lot easier way of doing this. It could have just gone to the function. But let's see if this works. This fires at all. And bytes 0. There's a lot better way of doing this. Let's go into here and assert that num bytes per instruction is greater than 0. So instruction. And so what he so what is this called? Start address, p start address, read byte x 6 u dd. Is dd an instruction? ED is not an instruction, so there's a problem here. Okay. Interesting. Well, I know why this is happening actually. Is because we're trying to disassemble something that's not an instruction. So actually, you know what? This is what we'll do. Default case will be an op of 1. We'll call illegal. And that should help us here. What is here? 6. Oh. Oh, I don't end. Do I not end the clipper? I thought I did. Oh, I guess I don't end the clipper. Okay, that's why. Alright, so we're making progress. And okay, nice. We have something. Oh, cool. So we have actually some disassembly. So let's actually compare this with the boot ROM. No. Starts at 1. We'll have to start at 0. Oh, we want to do this. So let's see if that works. Well, this is after. So let's restart it. Yeah. Pause it. Well, this looks the same. I'll do it. Yep. Zor A. Yep. Ooh. I think that's a bug. Let's see. This should be a 1-byte instruction. I probably screwed that up. Shell minus. Yeah, this is a 1-byte instruction. Oh. What is this? 4. Yeah, okay. Yeah. There we go. That's correct. Okay. But 7. Because the up and down arrows don't work. Let's see. It's 7. Oh, these are 2-byte instructions. That's fine. All the CB ones are 2-byte. JRNC 5 FF26. Minus FFA. Yeah, 14. And 15 is increment C. This should be. Yep. This looks correct. Okay. The next step is to add a bar here to start disassembling at a given address. So as you can see, this frame time is insane. It should be at 16, so it's a little bit laggy. So this, the code I just wrote is pretty bad. So this this iteration really needs to be fixed, and I'll have to try and think of a way to do that. Let's see. I'm probably not going to figure out a solution today. I'll probably have to think about it more. But I guess the next step should be to actually change this value. So this really just changed the start address value. Instead of 0, it should be the value in this text box over here that's going to be there. So should I do that tonight? Well, let's do it. That'll be my last thing. I think I really have a hard stop at like 11. So if I can't get it done by 11, then I'll stop by then. So this input text. So I'm literally copying and pasting from this memory viewer. This I can actually type in the arbitrary hexadecimal string, and it will zoom. It will go to that address. So just gonna really kind of copy and paste this. Why is the address input 32 characters? It should just be 4. I'll leave that for now. Okay. So this is what I want. Same line. kind of breakpoints, memory disassembly. Here we go. Let's go after or before the end child. This goes after the end child. So instead of range, oh, it's 32 characters because you can specify a range. Though I don't know if I actually support that. I copied and pasted this code from an example, so let's not worry about that for now. This is start assembling at and so what I put was ADDR press digits count. Zero. Oh, it's how many lines there are. No, it's the max. That's all it is. Zero times. I guess this is 4. So it's 4 per address. That makes sense. That is irrelevant to this. Okay, this is completely irrelevant. So this is 4. I'm going to take the 4 characters. Address. So scanf. So set scroll from position Y. Official start position. I actually want this to scroll to 0. Let me take a look at documentation for this. Really need to bind this to a key. Go to that's a declaration. Yeah, that's it. CR, that's it. Draw scrolling amount to make the given position valid. Use get cursor posts. Get valid positions. I guess what we want to do is this. Get cursor start position. Maybe. Or not. Plus Y. Okay. No, there's no conditional here. I want this to do is for now. Instead of current address, let's make this disassembler start address. Okay. And what I'm going to do is make this static for now. That's obviously what I'm going to eventually do is put this. I have a debug struct, and I'll put that in there. But for now, I'll keep this static. Let's do debug struct. Let's see. So begin child. Oh, this has to be. Can I just put 0? Let's see if 0 works. It's not. Let's see. Feel this definitely a crash. Zero. No, didn't do anything. Well, it's worse now. Let's see. Why is that? What screwed up here? What if I commented this all the time? Okay, so it's not that. It's a static that it doesn't like. So much start address. Start address plus equals. Then let's see. Okay. Oh, okay, that's why. Makes sense. Okay, so I need to. So actually, I do need a current address. I think this U16. Does this work if I make it U16? Is it? The flickering, I believe, is due to the fact that the um, the LCD RAM, the GPU RAM, actually changes the byte value of um, uh, during drawing of the screen. You can only access um, the GPU RAM at certain points, and if you're accessing it outside of a valid moment in time, that it returns FF, and so that causes that flickering because the the video RAM values keep changing. So, all right. So let's do this. Instead of what we do here is current 16 current address equals disassembler start address. That's what we want. It's not necessary. This is current address. Current address. And so oh, current. Start address. Current address. That's why. There we go. That's why. Okay. Um, so Right. So if we start disassembling at 1. Oh, nice. Okay. We see. There's a lot of stuff in there. Okay. So if we start disassembling at 16, it starts at 16. Oh, cool. Okay. Um. So, I'm just curious about this. I don't remember at the memory map what FF0 is. Let's see. So it's under GPU. Oh, it's under video, I think. Display. Oh, I guess it doesn't. High RAM. I'm not sure what FF00 is. Oh, it's a joypad input. Okay, makes sense. Okay. Just checking the joypad input. Interesting that this is. Oh, I mean, it's possible that these are just data values and not really actual instructions. Okay. So this looks pretty good so far, actually. The only problem is that getting this really slows down the system. But I'm okay with that for now. The main reason I'm doing this is so I can compare the source of this to the source code of the test ROMs and see where the faulty instruction might be. So I think this is a pretty good stopping point for today. If anyone has actually any questions, feel free. I'll wait another minute or so. Feel free to post in the chat. Else, you can contact me on my Twitter at dboxer91. So, let me just wait a minute. See if anybody wants to ask a question. I might or might not work on this offline. It's possible I'll at least maybe try and find the bug off stream, and then if I find it, I can present it. Else, I'll do some debugging on stream. That'd probably be helpful. Okay. All right. So I'll end it right here. Thank you everybody for joining me. And I should be posting, hopefully this actually archived, so I can post this on YouTube. Alright, thank you very much. Bye.